So, thought I'd talk a little bit about an old project I came across here. I'm cleaning up, packing up. This one actually goes back to when I was in school. Did this as an electronics project, even though it's hardly electronic. What I built was a coil gun. Now, for those who don't know, coil gun's basically a solenoid. You put power through a coil of wire, it becomes a magnet. You have a metal slug that gets pulled towards the center of the magnet. You shut the magnet off at just the right moment, and the slug keeps on flying out the end. Takes a lot of current, and generally speaking, the way these are made is you have a bank of capacitors like these. You charge them up. These work kind of like electric springs almost. It's a computer-controlled system of some kind, either a circuit board or something else you rig up, in order to correctly time that delivery of power for optimal yeetitude, as it were. Now, one thing that I thought about when I was designing this was a matter of how capacitors and inductors work. We were learning about LRC circuits at the time, which are circuits with a capacitance, an inductance, and a resistance. And the way that those behave is they create a sine wave. Sometimes it's called ringing the circuit. And in very simple terms, my kind of analogous terms, you put a lot of power into the capacitor, and the capacitor builds up potential. Acts like a spring. You're tensioning the spring. That power, when you close the circuit so that that power can then flow, will flow into the coil or the inductor or the electromagnet. Same thing, all three times. And what happens with these is these work more like a flywheel for electricity. Once there's electricity flowing through them, it wants to keep flowing. It wants to keep on going. It takes a while for the power to get started flowing, and once it's flowing, it doesn't want to stop. And with it connected up to the capacitor again, what will happen is the power will flow from the spring into the coil. And then once the coil has all the power going through it, it'll want to keep going, even though there's no tension pushing it anymore, and it will try to push that current back into the capacitor. And the capacitor will build up a potential in the other direction, and it will push it back through the coil again, and it will do a damped sine curve. It will go high in one direction, then it'll go down to zero, it'll go low in the other direction, it'll go high in the other direction, but not quite as high. There's some power loss there, and eventually it trails off. So the idea that I had was, okay, what if, since you have to shut this coil off at just the right time, what if you could carefully tune the size of your capacitors and the size of your coil such that at the crossover point where that flow goes from highest to zero, before it starts going back the other way, from high to zero, that 0 point hits right as the metal slug is flying through the center of the coil, and as it tries to come back the other way, the slug's already gone and doesn't react to the magnetic field as it rings out. Now, obviously, that's a pretty tricky thing with a bunch of math that I never actually did because of this. So my original design was a relay, a bridge rectifier. I had a lamp for a current limiting to form a current limiting resistor. A bunch of these capacitors out of a power supply from some piece of equipment that was being thrown out. I don't even know what it was. And this coil, which I made on a piece of PVC pipe. This is actually a rubber-coated aluminum clothesline for the wire. The number of turns was carefully chosen by using up the entire spool of clothesline wire and then just calling it good when it was done. And it was quite simple. I had all of these ganged up in parallel. use the lamp to charge these straight from mains, and that worked out pretty well. Charged it up to 120 volts. Well, actually it was 170 something DC, which is actually well past what these capacitors are supposed to be good for, but they didn't explode, so that was good. And then I just simply, once these were charged, I just simply dumped it right into this coil, and it worked. I wasn't expecting it to work. I was expecting to have to do more tuning. I was expecting it to kind of like pull itself into the middle, and that's the sum total of it. And then I'd have to go back and I'd have to refigure it and that sort of thing. But no. And since I wasn't planning on it using, I didn't tie it down. So the slug, which at the time was a piece of rebar about the size of this socket, went zinging across the room, nearly busted out a window, and this whole assembly went yeeting itself onto the floor in the other direction because of recoil. And it worked first time. And so something I'm going to be looking into doing here shortly, right now this is getting boxed up, but shortly, is to actually do the math, figure out the correct capacitance and inductance, and from the correct inductance, figuring out the right number of turns, the right diameter of turns, the right length, gauge of wire, all that sort of thing. Do that actual math. And actually something else that I've gotten, but I actually have an LRC meter now, and I just got an oscilloscope. So one thing that I'm thinking of doing is also examining how the inductance changes as not only the inductance of the coil based on different diameters and whatnot, which is well established, but also how the inductance changes as the slug flies through the coil. And then once I think I've got a good mathematical approximation, because I have these, and they look really cool, and they're big scary capacitors. These are going to be my fixed variable to actually figure how the coil I choose changes based on where the slug is inside the coil. Do all that sort of thing, and then actually be able to hook it up to an oscilloscope and actually check it and actually see how it works. With the idea being of building a coil gun that perhaps handheld size that operates at the magnetic saturation of the metal slug, so as fast of an acceleration as possible, but no more. We don't want to waste any current here, and get the highest velocity out of it with no microcontroller control, no IGBTs, no nothing. Just one switch, click, and it goes. And I have a bunch more stages with that project, some other ideas I want to try, but for now that's going to be that. And just digging this out, I wanted to show you guys some of my back burner projects, talk to you guys about them, and see if people are interested. And if there is a lot of interest, I'll probably fast track this. Take it, break this box back out, and get started on it sooner rather than later. So, if y'all like it, let me know. Otherwise, I've got a whole bunch more stuff. I'm going to be going through a bunch of my old projects and seeing how everything goes.